and welcome to our tutorial series about line differential protection. My name is Nina Hühn and I am technical expert for differential protection.
My name is Philipp Stachel and I am the product manager for ZProtect 5 line differential protection devices.
As you may realize, we pre-recorded the previous sessions, but this one is live. So please enter your questions into the Q&A field on the upper right side in this web application. We collect them and try to answer them during the session or respond later, depending on the time. This includes all the questions collected in the previous session.
The webinar series was split into 4 sessions. You can see them on this slide here. So the first session was about the line differential protection basics. In the second session, we presented you some backgrounds about the protection interfaces. In the third session, Nina presented you the configuration in Dixie and also some testing aspects. And there was also a fourth session where Nina presented you the compatibility between the ZProtect 4 and the ZProtect 5 series. We are very impressed and happy that by today, more than 2,000 people watched at least partially the webinar. During these webinars, we collected more than 100 questions, which we want to address in this question and answer session, at least partially. So we tried to group them thematically into question blocks. So there had been some general questions, of course. There have been some line differential protection compatibility questions, question about the protection communication, and also CT, towards the CT and VTs. But there have been also some general webinar organizational questions, like the one, where can I download the presentation? And this is
maybe just start with the simple question. The presentations and the recording, of course, you you can see it and you can download the presentation. You simply go to your invitation email and click on the link, go to the recording, and there you see the recording, you see the presentation. And it should already be visible for all 4 sessions, and also a slide set for this Q&A session. Okay, so let's jump right into the more difficult questions. And here the first one is a one for Philip.
Okay.
So it's about the topic, differential protection versus distance protection. So is there a line length where line differential protection is preferred over distance protection, or vice versa?
Yeah, okay, this is... as you know, the line differential protection and distance protections are two different protection principles. And what I presented in the first webinar was like advantages and disadvantages of the line differential protection, while the advantages are the disadvantages for the distance protection, and vice versa. No? If I say that there's no VT required for the line differential protection, then of course you need it in the distance protection. While the line differential protection requires, of course, a communication channel, which is not the case for the distance protection, at least if you are not doing teleprotection. Mm-hmm. So, but the question here was regarding short lines and cables, which I also brought up at the first webinar. And this is a bit difficult to make a calculation for this, because you have to take into account the measurement errors from the CTs and VTs. Typically, you have about, for the CT, about 3%. For the CT error for the VT is also about 3%. So this may give you an impedance error in the range of about 6%. So this has to be taken into account, that you cannot protect very accurate at the gap between the zone 1 and the zone 2, which needs to be considered for the distance protection. But also the relay settings is a limitation, because the relay needs a minimum measuring voltage for its accuracy claims. And for the ZProtect 5 series is about 1 volt secondary. And also the lowest relay setting impedance is a limiting factor. So you will end up in a few kilometer practical application where the line gets a short line. And this also depends on the source to line impedance ratio in micron market, often used as SIR ratio. So here, if you have a strong network, then in the back of the relay, then you will see for short circuit that the voltage does not drop too much. So a short line will be a few kilometers in application. While for a weak network, the voltage drop will be so high that you may only protect very short lines. So the application there is even worse with the distance protection, and especially for these short lines, the line differential protection as a unit protection has a lot of benefits. Okay, so I think I hope we could answer this one. Yeah, the next one, maybe for Nina, for you, is about the interoperability. Can we mix line differential protection devices of different manufacturers?
Short answer, no. But let me give you some more details about it, what we are capable of and what we are not capable of. So we can say we can work with other devices within our Siemens protection family. That means a ZProtect 5 device can work together with a ZProtect 4 device. This is what I presented in the last session of this webinar series. There are some boundary conditions, but it is possible. And we are the devices can work together, ZProtect 5 devices with, of course, other ZProtect 5 devices. And there is also no problem if they have different firmware versions. So this is also possible. And it is also possible if these are different device types. That means, for example, a 7ST82 can make a line differential protection together with a 7UT. Something. So within the Siemens protection world, we are all devices can work together if you consider some boundary conditions, I would say. What we are not capable of is to talk with other devices from other manufacturers because we are working with a proprietary protocol. But I would say no other manufacturer is capable of doing this. So, yeah.
Yeah, but if you move away from these proprietary protocols and move to some standardized protocols, for example, synchrophaser or something based on IEC 61850, like sampled values, then you may have the possibility to exchange at least the data from a remote merging unit to your protection device, and you can do a centralized line differential protection. Okay. Actually, we did some tests together with Hitachi Energy and with a customer CKW in Switzerland, and showed in some laboratory tests that it's possible to do a centralized line differential protection in one device. So let's see how this will impact the future. Also with the line differential protection running maybe on a central computer as a centralized protection.
Okay, interesting. Okay, so much about the interoperability. Let's talk algorithms. So why there is no slope setting for the line differential relay?
Yeah, this is something a bit special for the Siemens devices compared to other manufacturers. I tried this to address this in the first webinar, where I presented different characteristics. The dual slope characteristic, alpha plane was also a topic. And with the Siemens devices, the differential is calculated in the same way as with other manufacturers, but the restraining contains already the CT errors or stabilization, sorry. The restraining contains signal components for the restraining coming from CT errors, but also from signal distortion or from the channel synchronization, from asymmetry in the channel. And especially the stabilization towards the CTs is also a dual slope characteristic in the background. So this single slope characteristic can be also calculated in a dual slope characteristic. You will see this if you do some testing with the Omicron, that it appears that there are also some steps in this characteristic. Maybe it was not so clear. I'm sure we will make some. We will provide later on an application note where we also show how to test the Siemens line differential protection characteristic using, for example, Omicron tools. No?
And I would say maybe for the end user, the benefit is that the settings are very easy for our characteristic, and we are always like as sensitive as possible.
As needed. This is maybe this is the biggest differentiation between the dual slope characteristic. Then that this calculation for the restraining only takes into account as much as needed. So this is the idea, and not a fixed characteristic. Yeah. Okay. So a question, I think, for me.
Yeah. Sorry, confused about the slides. So let's talk about CT saturation in inrush. This is also like part of this restraint characteristic. So the question is, how is CT saturation handled in the line differential algorithm? And the second question about this topic is why fifth harmonic blocking is not available in the 7SL87 relay in the 87L function.
Yes, this is also a topic which was presented in the first webinar, and also linked to this single slope characteristic. As I showed already in the previous slide, the calculation for restraining is taking into account the minimum threshold, then the component which comes from the CT errors, which I explained before, and now it comes to a component which considers stabilization component based on a signal distortion. What's meant with this? If you have a CT saturation, and this is an example, this red curve would be a signal, a secondary signal of a CT with CT saturation. So you see that the parts of the current waveform, the current gets to very low values, while the blue curve would be the ideal sinusoidal current signal. So the deviation between the measured and the ideal sinusoidal signal would be a measure on an additional restraining component which is taken into account. So sample-wise, we analyze the difference between the measured secondary current, the red curve, towards the ideal fundamental signal component, and this is a measure for the adaptive stabilization. And the same applies if you have a fifth harmonic in your current signal, then you have also a deviation from the ideal sinusoidal signal. You will have some overshots in the current signal, and these are also some, like here on this slide, these green areas, which will then be taken into account for an additional adaptive stabilization. So there is no setting by the algorithm by itself does taken this into account.
So again, maybe we can say it's like user-friendly because we don't need any settings for this. It's already included in our algorithm. Okay, then come to the next question is regarding rated values. So in Dixie, there are some settings where you can set the rated values, and maybe this question came from this fact. There are some multiple positions where you can set this. So the question is, the rated current in the line general setting must be the same in both devices. Yes. Should the rated current be the same as the CT ratio? The first question. And the second one is, what about the rated nominal current in the circuit breaker general settings, Nina? Okay, yeah, I understand where the confusion maybe comes from. A lot of places to set rated values. So let's take a step back and look on which positions in Dixie you set the rated data. The first point where you set it is the CT nominal data. That means under the measurement point, you make the settings for the CTs. What is the ratio? What is the primary rated value? And what is the secondary rated value? Here it is important to understand that for the line differential protection, it is not necessary that the CT ratio and the CT rated values are the same for both sides of the line. You see that also on this small example on the right side of the slide. Here we have on the one side a 600 amp to 1 amp CT, and on the other side, an 800 amp to 5 amp CT. That means even the secondary current must not be the same. So here's no problem. And it even must not be the same CT type. This can also be different. Then we have the setting nominal data of the protected object. In our case, the protected object is a line. So you find it under the tab line and general data. So here you set the rated current. In this example, it is set to 472 amp. And this is the value that must be the same for both devices or for all devices within the topology. Only exception is when there is a transformer in the line. Then the rule is that the rated apparent power must be the same on all devices within the topology. And last nominal data setting is the one you find in the tab of the circuit breaker. So here it's under circuit breaker in general. Here is also a rated nominal current. And for this setting, it's important to understand that this is the reference value for the percentage values in your Dixie settings. So when you are working with the percentage values, this is where it is always the reference. Yeah, I would say if you don't want to get confused and work in percentage, then it's a lot easier if it's the same in all devices. But yeah, I would also say, I don't know if really a lot of people working with percentage settings. But yeah, this is where this nominal value is used for.
Maybe it's better to use in the primary settings because then you're not confused, no?
Yeah.
And this is also provided by the Dixie, no? You can set the device in secondary, primary, and percentage values.
Exactly, yeah.
So this makes a benefit, I think. You already said something about the CTs. There was another question regarding different type of CTs. How they really handles different CTs at the substations. If the CT ratio or the CT class is different, how about another difference between CTs? No, the second part I don't understand, but maybe
yeah, let's see. Okay, so I already said the CT ratio and the CT type must not be the same on both sides. For the CT type, we recommend that it is the same, but it's not mandatory. And the CT settings and the CT arrows are considered also in our adaptive restraint algorithm. So you see on the upper side of the slide, there's red term. This is the one for considering CT arrows. And for this term, it is very important that you make the settings correct. And here you see on the slide, this table looks complex, but here you simply see for all the CT types, the settings that you need to make for CT arrow A and CT arrow B and the switchover point. And of course, this must fit to your real setup on both sides. Maybe a quick repetition where to set it and why we have two factors for that. The setting is made in the tab measurement points, in the measuring points, where you set the CT ratio. You set also the settings for the CT arrow. And these CT arrow describe this linear range of the CT that you see here on this diagram on this slide. So at the beginning, the CTs are transmitting the current correctly in a linear range. The bigger the current is also on the secondary side. And then if the currents are still getting bigger and bigger, at some point the CT starts saturating and we are no longer capable of transmitting the current correctly from primary to secondary. But here it's important to understand the CT arrows are only describing the linear range of the CT. And here the idea is that for currents that are in the range of the nominal current, we want to work with a smaller CT arrow. And when the currents get bigger, that means we are in the area of fault currents, we work with a bigger CT arrow just to be sure that we don't mall trip, that we are stabilized in case we are in the area of fault currents.
So it's more sensitive for the range where we have a nominal current and a higher restraining in the range where I expect the fault currents of you.
Yeah. Okay. And this is meant with the setting. And the switchover point is where the relay switches between these two arrow settings. And yeah, the relays exchange percentage values in relation to the nominal line current. And this is what makes the currents from both sides comparable. It means when we have different CT ratios, the relay always calculates these values into primary values, and then set it into relation to the nominal current, and this is then sent to the other side, and there it is. Same process, and this is why we can work with different CT ratios.
Okay, thank you.
Okay, now I have a question for Philip about maximum and minimum line lengths for our 87L. So what is the maximum and minimum distance for a CPROTEC 5 line differential protection topology? For transmission lines, do you think that it's technically defendable to do a differential protection?
Okay, for the first topic, regarding the maximum line lengths for the unit protection, line differential protection, maybe is the communication path the limiting point, no? And there is no definite value for a maximum distance between two devices for the line differential protection. The limiting factor are the communication modules and the options you have. We normally use the communication modules with an SFP. And the SFP for the communication modules in the devices have a limitation for up to 100 kilometers. So, for example, this is such a communication module, and the used SFP in the module is such small unit. We have a limitation for the modules for about 100 kilometer. If you need to protect a longer distance for the line differential application, then you can use the fiber optic repeater, which I also presented I think in the second webinar. Yeah, and here we have also SFP options available which have a longer distance of about 170 kilometer to cover. If you have even longer lines, then, and you have maybe a power supply in the middle, then you could have such fiber optic repeaters back to back in operation, and you can cascade them.
Okay.
Normally, you're using single mode fiber optic in these applications, but if you have, for example, a communication network in between based on SDH technology or MPLS technology, then you can have even longer lines which you will protect or will be able to protect. Regarding the shortest distance, of course, if you're using very strong fiber optic SFPs, then you need some damping devices in between. But there are also options which where you can also order, like this one with a multi-mode fiber optic connections, 820 nanometer. There's up to 1 kilometer, 1.5 kilometer communication possible. But if you have such a short application, then it's also considerable to use the stub differential protection for these devices. And for the stub differential protection, there was also a question. Can we use the stub differential between the first and the second CT, so first zone, and the line differential protection between the first and the third CT? Maybe it's better to explain on the figure.
Yeah, I'm not sure if this picture completely fits to the question, but I hope it helps to understand what we are capable of when it comes to the stub differential protection. I found this picture in the manual. So here in this example, we have like this circuit breaker and a half application with the two CTs on the positions 1 and 2, and the third CT on the right side on position number 3. In this example, in the manual, we make a stub differential protection between the first and the second CT. So because they are close by. and an overall 87L differential protection between all 3 CTs. So this is like completely possible, and the benefit of this solution is that you only need 2 devices, because you have the stub differential protection running and the 87L protection running in both in one device in parallel, and both currents from CT1 and from CT2 are connected to my first device and sending then like both measurements to my third device. And for this, I want to show you in Dixie real quick how to configure this. So I prepared a little Dixie example. When the studio team could please, thank you, perfect. Now my Dixie should be visible, thank you. I simply created a 7SD86 device, and this 7SD86 is this device where we have this application template available, what I just showed. And the position where you start with such kind of stub differential protection is when you go to the measuring point routing, you see when it opens, you see we have here 2 current transformer inputs for the CT1 and the CT2. They are here assigned like this. And under function group connections, here it is under protection function, under measuring points to function groups connection. You see here both CTs are assigned to my function group line. And that means the device like sums up those 2 CTs. And my 2 protection functions are then running within my function group line. So when I go down here, you see here we have our 87L line differential protection, which is like to cover up the whole application and the overall protection with all 3 CT locations, I would say. And we have here also our 87 stub, which is only like doing a differential protection between the first and the second CT. Okay, I hope this more or less fits to the question, to the example that is meant in the question.
Mm-hmm. Okay, thank you, Nina. There was also, we highlighted in our webinars mainly the line differential protection and focused on the communication using exchange of phasor data. Mm-hmm. But there was, maybe we missed out this one. There's also a question about additional information which I can send over this communication channel. And this is what we speak about remote data. And there was a question, how do I exchange additional information between 2 devices via the protection interface? And how many binary signals or measured values can be transmitted?
Okay. So yeah, it's definitely possible to also exchange binary signals, measurement values, whatever you want, between the 2 devices via protection interface. And the 2 devices or 2 or more devices are always like exchanging data bars between the 2 devices. And these are like freely configurable for the end user. And on this slide is, this should explain these data bars that are exchanged. It is split in 3 priorities, 1, 2, 3. And the first priority signals are sent with every telegram. That means every 5 to 10 milliseconds. The priority 2 signals are sent with at least every second telegram. And the third priority signals are transmitted at least every 100 milliseconds.
So the user can prioritize the data he wants to exchange and how often this occurs.
Exactly, yeah.
And is there a limitation in the size?
Yes, so there's also limitation on the size. We have like limited space for each priority. And this is also written here on the slide. You also find this information, what I put here on the slides, more detailed also in the manual. So this is just like an excerpt. This first table on the slide shows the available bit for the minimum cancellation baud rate of 512 to 248 kilobits, because the available bits that are exchanged in my data bar depends on the baud rate that the bandwidth that I set. Exactly. So here you see for my type 1 protection interface communication, that means type 1 is the one for line differential protection. You have with priority 1, 48 bits available, priority 2, 128 bits, and with priority 3, 385 bits, 84 bits, sorry. And each signal type has a different size. So a single point indication, for example, if you want to transmit this, you only need 1 bit of my data bar. If you want to exchange a double point, you need 2 bits, and measurement values even need more bits, like 32 bits in total. Okay, so the question of how many bits can be exchanged depends on the baud rate, and it depends on which kind of information you want to exchange between the two devices.
Okay.
And now I want to jump into Dixie again, please, because I want to show you where to set these remote data. And you found this under, and you navigate to your device under communication mapping. Minimize everything we don't need. So here you see the selected protocol. In our case, we only have the protection interface available, type 1, because we are talking about line differential protection. Here are all the signals available that are in my device. And I don't know, if you want to transmit the circuit breaker ready signal, just as an example, to the opposite end, then you go to navigate to the signal you want to transmit. And then you have here the signals for receive, or the tab for receive, and the one for transmit. So here I can define, okay, which signals are coming in, which signals are going out. So when I want to transmit, I don't know, the trip command to the opposite end, then I click here on the T bar, and here I enter the priority which I want to send the signal. So for example, I want to send the trip command with priority 1, then I enter a 1 or a 2 or 3, whichever I want, the priority I want. And then you can, okay, only in X, not a 1, sorry, this was my fault. So here I enter the priority level. So here you simply define, okay, I want to send this signal, and here I enter the priority. This was my fault, so I want to send it with priority 1. And then I enter, okay, on which position of my data bar this signal is sent. So of course I start with a 1, and then the next signal must then start with a 2, or when the first signal is like a measurement value, then of course, then I have to consider how big is my measurement value, then the next free position must be entered there. But of course, Dixie will help you here, so you don't have to know which is the next free position. Dixie will simply say it. So maybe I can show it real quick. When I also want to send a second device, then I cannot enter again a 1, because the next free position would then be the 2.
And it's also blocked that I enter a 100, because there is no 100?
Yeah, I would say there's also a maximum limit.
Okay, thank you.
And of course, sorry, one more point. Of course, I have to define it for the send device, and I have to define it on the receive device. So on the opposite side, I'd have to do the very same in the tab receive, that I receive something with priority 1 in the position 1. So on both sides, I have to define this.
But a device which sends on a position 1 may not expect something to receive on the same position, because normally you send only on one position, and other devices may send on other positions, so you pick up the right information.
Yeah, good point.
So you have to make, or from the application point of view, you have to consider on which position which device is ascending, and others may subscribe the information. Okay.
That's true.
Okay, thank you, Nina, for this X-course in Dixie. Not a problem. There was also one question about the fault locator. Can we use the fault locator in the line differential protection? Yes, you can. If you have the voltage signal available, you can have impedance-based fault location. But also the advantage for the line differential protection is that you already exchange information. So you can have a double-ended fault locator using the same communication path.
Okay.
And this gives you a higher accuracy, but this is only possible if you have a two-ended line differential protection. So you have a multi-ended line differential protection. You cannot make a double-ended fault location because the in-feed will not be considered correctly in this case.
Okay.
This is a limitation. Yeah. Then the last one. Sorry. Yes, wrong computer. The last one was regarding Dixie license model. Nina, this is something for you. Can we use the Dixie license, a free version on our system? What are the differences between the different Dixie license models?
We have 3 different Dixie licenses. They're called Compact, Standard, and Premium. And of course, it depends on what setup and what projects you want to realize. Compact is a free of charge version that can be downloaded, but here it is limited on only one device of our modular devices and non-modular devices, 8 devices when you have compact devices. For the license models Standard and Premium, you have unlimited number of devices. And you also see this overview. I don't want to go through the whole table. You find it in the Dixie manual if you are interested in want to know which Dixie license you want to buy. For example, one big point is also the IEC 61850. If you want to do like a whole IEC 61850 configuration, this is only possible with the premium license.
Okay.
So it depends, I would say. But for the basic operation or for connecting to a device, if you just want to connect to the device to retrieve the data, therefore we have this free of charge compact license for Dixie.
Okay, so it's possible to have a Dixie download, which takes some time, of course, and also installation will take some time. But at the end, you have the possibility to work with protection functions free of charge.
Exactly, yeah.
Okay, good. Okay, so we ended up with our prepared questions, which we got from the webinars, which we already sent out. So webinar 1 to 4. So we collected the questions and prepared these slides. Now we have 20 minutes left, and we would like to go through the questions which came on the chat to make this live session.
We are curious what comes in. Okay, maybe we start with the beginning of all questions.
Is it the beginning? Okay.
I don't think.
So we have a prompter in front of us, so we can see the questions, and let's try to read and answer. No? Okay.
But maybe we can you please scroll to the top, that we don't miss something.
Okay.
Okay.
Okay, that's the one I would like to inquire about, application line differential, in particular for short transmission line. I think we answered this one. There is one question regarding when to use the distance when the line differential protection. What considerations should be taken into account when using line as a primary backup? Does it work? What considerations should be taken into account when using differential protection as a primary with a backup IED? So backup maybe a distance or overcurrent, I would expect here. How does it work at the other end if the primary IED is switched off at one side? So line differential is switched off at one side. What happens to the other side? Can you answer this?
I can at least say that it will be automatically blocked. If the one side is offline, then of course the line differential protection is blocked. and then the backup protection can jump in, like for example, distance protection.
Or channel fails, then you can also configure then if the channel fails, distance protection picks up or overcurrent protection picks up.
Yeah.
Also, if you have a multi-ended line differential protection where you have more than 2 ends, there could be considerations where you want to work on one circuit breaker and you want to lock it out. So there's a difference. Lock out is also possible.
Yeah, okay.
In this case, then it's not a 3-ended application anymore, then it's a 2-ended line differential application. So you can lock particular line ends out of the topology, we say.
Okay, next one. For line or cable having different CT ratio and characteristics on both sides, an example, 1000 to 5, or
with a knee point voltage of some specification, okay?
I would say we also had this information prepared in the slides, so yes, this is possible.
This is possible, but you have to take into account that using different CT classes that you may have different values which we recommend to set for the CT error A and B.
Exactly, yeah. Okay, next question. Hello, thank you for providing such a wonderful experience. My question is, when is differential protection a better choice for line protection as compared to distance protection? Distance protection is more economical and acts as backup protection for the next transmission line. I think you also answered this one.
Yeah, I think this is in the webinar 1 where we have the advantages of the line differential protection. So everything which we put in there. So for example, if you consider a lot of power swings, or you have a tapped line, or you have a very short line, then your unit protection with line differential might be a more reliable option. But of course, you have to consider how you exchange the data in between the relays. So you have some kind of communication path.
Yeah.
Okay, then was one. Is GPS important for line differential with monomode or multimode optical fiber? Nina.
Okay, I would say in this question, there are some mix up maybe because the GPS doesn't have something to do with monomode or multimode. GPS is only mandatory or recommended if you suspect asymmetry in your communication path, and you need like an external synchronization source when you work with line differential protection over IP systems.
And this could be based on GPS, which is a global navigation satellite system, or this could be also some clock source like a PTP signal, where you have a 1 pulse per second generated. So you can synchronize the devices in such an application using different synchronization sources.
Okay. So next question is more like a Dixie organizational question. Hello, I would like to have access to the software for research and training for a period of 30 days.
This we answered, I think, in the last slide.
Exactly.
So this is possible, yes.
So next question, I think I read it because it's something for you. Hello there. In part 1, the characteristic of the alpha plane were presented. Does Siemens intend to use differential protection through the alpha plane?
No, we don't. In this webinar session, I wanted to express the different characteristics which are available in the market. So dual slope characteristic, our adaptive principle. Then we had the alpha plane, and I think it was also phase comparison, which I presented. And this was only for showing you the overview, what is available in the market. They all have their pros and cons. And I would not say the one is better than the other. We have a lot of experience with our adaptive method since the CPROTEC 4 series, and we will not change this. And so there will be no alpha plane in the Siemens devices, sorry.
Okay, I think the next one was also already answered by you. What is the shortest transmission distance not recommended for distance protection?
Yes, this is the one with the source impedance ratio. Difficult to answer. We tried to address this a bit in this prepared answers already. So it's not so easy to say. It depends on minimum settings of the IAD, but also on the minimum voltage which you have on the secondary on your protection relay, which is for Siemens 1 volts. So this needs to be fulfilled.
Okay.
So something with testing. You did testing, so I make it. Define protection site substation power transformers on routine test for short circuit, open circuit, low voltage magnetic test with neutral, without neutral, core balance test, DC restraint, HV side, LV winding resistance. There's a lot of testing here, which is with these questions. This is difficult one. Can we answer this one?
I don't think I can answer this spontaneously.
Not straight away.
Yeah, we will come back to you.
We want to capture all the questions, and the idea is to address in written to all the questions at least an answer or a short answer. And if we don't understand a question, then we will also write, please explain in more detail or something. So I take this in this group.
Yeah.
Okay.
Okay. Define CT adopted ratio.
Different CT links for relay settings. We have the possibility to set the CTs and the CT ratios different at the line side. I think you explained this very, very well. Only in case you have a transformer in the protected zone, you have to take a bit more care about that the rated power is the same. But I think this is not a problem. Also, the secondary CT value, if it's 1 amp or 5 amp, can be different. Also, the type of the CT could be different, but as Nina already said, this is not recommended. No?
Yeah, possible.
If possible.
Okay. Maybe I read the next one. Hi, can you please explain about CT sizing for line differential protection? I would say here I also recommend you take a look in the manual because here we have a dedicated chapter about CT sizing that is required for line differential protection. Yeah.
So especially for the combined devices where you have distance and line differential in one device, which would be the 7SL 86 or 87 or the 7SX 85, then you have maybe different applications, and then you have to think about what is the highest CT requirement. Comes it from the distance protection or comes it from the line differential protection? But as Nina said, in the manual, there's a section about CT applications or CT requirements.
Yeah. I think it's explained very well in the manual. Okay, if by mistake we purchase a relay for 100 kilometer, is it possible to use it for short distances, such as 1.5 kilometer?
Okay.
So I would say yes, this is possible. You just need to make sure that you may need a damper,
damping device
in between. But I think also this hint is can be found in the manual. On what's the minimum distance here?
It's also a question of what type of fiber is laid. No? I would expect it was a 1.5 kilometer distance. Maybe there is multi-mode put in the ground and not single mode fiber optics. But this needs to be checked. The other questions regarding the maximum power, which the SFP will output for the 100 kilometer SFP, we recommend to use damping device, which is an attenuator. So it just takes the optical power out of, reduces optical power to not overshot the receiver at the other side. So there's is needed, I think, from 20 kilometers, but this is explained in more detail in the manual, in the hardware manual at least.
Next question about length of communication passes. The SFP modules for 100 kilometer can be used for line lengths about 110, 150 kilometer instead of using repeater. So here the question is maybe no. So I would say it's maybe.
It's a maybe.
It's a maybe.
It depends on the optical budget. No? What we specify in our hardware manual is the minimum optical output power of the sender and the maximum sensitivity of the receiver. And in between, we speak, this is the optical budget, minus 3 dB as a safety margin. And this is what you can spend on your channel. So there's damping on the fiber, there is damping on joints, on splices. Okay. And if you know your route, how many splices, how many joints, or even have measurement data, then you can find, for example, that the 100 kilometer SFP or module for 100 kilometer, which we write down in our order book for 100 kilometer, can be applied for maybe 115 kilometer or so. So yes, this could be the case. So this is not the value is an estimate based on typically found number of joints or splices.
I think we do we have an example calculation in the manual? Okay.
Not the menu maybe, but also in the webinar. I think in the second part I had some frequently asked questions. There was a slide where I presented.
Perfect. Then you can
maybe have a look again at this one.
Example helps.
How do I know the software delivered to us by Siemens is standard or compact?
I would say if you activate your license, it is in the upper right corner of your Dixie software written which type of license it is.
For me, there is developer mode. No, just joking. Okay. Is it possible to have a large difference in the knee point voltage for the line differential protection ends? For example, one end with 3,300 volts and the other one with 950 volts. 950 volts knee point voltage is also very big, from my understanding. But
this is more your specialty.
Mine. Okay, you put it to me.
Yes.
Okay. Now this is a question regarding the CT sizing. Here it belongs together with what Nina said. There's a section in the manual where we have some calculation. What's the minimum required knee point voltage? Here you have two different CTs with a different saturation characteristics. So I would expect the one with the 3,300 volt will saturate much later than the one with the 950 volts. But even 950 volts, I expect this is a huge CT already. So there must be a big burden in the secondary. But this is very application-wise, so maybe it's good to send the questions to our promoters or experts later on. Okay.
I just saw an interesting question that we jumped over. Maybe scroll down a little bit, please. Here it is. Okay. I actually don't know the answer, but I think it is worth to read it because, sorry, it may have been mentioned for transformer differential. Is there an input for online tap changer position? I think I don't know, but it is an interesting question. And this is something I will definitely check afterwards.
Yeah, I also don't know. This is
good question. Not yet mentioned.
Setting. What would be the main recommendations for setting differential protection for long submarine cables?
Are there any special recommendations? I don't think so.
Long submarine cable. A long cable has a high charging current at least, so has a high capacitance towards the shielding. So ICE will be very, very big. So this needs to be considered for the minimum setting for the line differential pickup value.
And maybe we can recommend to work with the charging compensation.
Yes, in this case, you will need VTs at both ends. If you have these available, then you could also use to increase the sensitivity towards the fault current, the capacitive charging current compensation. Maybe it's worth to do this. on the you don't write here what's the length, but I think this is not the limiting point because the cable will not be so long. Otherwise, you will need some transformers, compensating transformers in between. Yeah. Good one.
Okay. Yeah, I would say almost 60 minutes full, so I don't know, three more questions or something like that.
Okay.
What are the limitations of use the devices in 220 kV line in Bangladesh? Is it environment independent? Here, I would also say you find in the technical data of our manuals, like the conditions that we expect or that we need for our devices.
Yeah, environmental depends on the question. Maybe from the point of the soils in the air or something, there are some tests and some normative testing which the device on the C-Protect 5 overall range fulfills. So maybe this needs to be checked if this is sufficient for the situations in Bangladesh. Can I upgrade firmware for Dixie 840 to 940 to 964 version without affecting configuration already done on the IED?
Yeah, here I would say it is possible to upgrade the firmware without updating the configuration. So an older configuration call can always work with the newer firmware. Here the rule is it is not possible the other way around. So the configuration always needs to be older than the firmware. And yeah, in this case, I would say definitely, yes, you can leave the configuration in the version it is.
Of course, and if the older configuration does not support parameters which are available in the newer firmware, then this upgrade will not provide the functionality. No?
That's true, yeah.
If transformer is used in the protection range of the line differential, second harmonic blocking is available. However, fifth harmonic blocking is not available. What is the reason for it? Oh, okay. Second harmonic blocking is available. I'm not so deep in the in the settings which come up. There's a bit that what I explained with the signal distortion. So even if it's not available to have the fifth harmonic blocking available as a parameter, it will be considered in the restraining in the differential calculation because there will be a variation from the sinusoidal signal, and this will be result in stabilization, additional stabilization. Yeah,
maybe we can also add that when there is a transformer in zone, it is possible that when switching on the transformer, an inrush current is suspected, and here we always have a high content of second harmonics that then can be used to block the protection functions during the startup of the transformer.
A fifth harmonic is more like overexcitation. So I think. Okay, so last question. Take a special one. Any special grounding is needed for 100 kilometer to 30 kV line distance protection in tropical environment? This is a distance protection question. So we take another one, sorry, off topic. What are the main, what's this?
Indications.
What are the backup protection for 87L? Backup protection for 87L?
Typically distance protection, I would say. And of course, overcurrent protection functions when you don't have the VTs for it, for distance protection.
This could be even in one device. If you have a 7SL 687, then you have the distance at the line differential in one device. Yeah. Okay.
Okay, say 60 minutes are over.
And we went to maybe almost all the questions on the chat. So very nice. So we had this aspect that it is really a live session. So we considered your questions. So this was important for me.
So thank you very much for your questions, for your interest, for joining all 4 sessions. And we are happy to welcome you to other of our EA webinars.
Yeah. Thank you very much also from my side. And as I already said, we try to address all your questions in a written way later on. Maybe on the download, I don't know. Let's see.
but give us some days. There were a lot of questions.
Thank you very much.
Thank you.
And see you next time.
Have a nice day. Bye.
Bye.